Hi, hello everyone. I'm Pierre-Loup Griffet. I work for Valve on most things Linux, and today I'll talk a little bit about GameScope and updates on its development and show a couple of quick demos. A little bit about myself. In 2007, I started being involved with the Linux graphics stack, mostly on graphics drivers at the time. In 2012, I joined Valve to work on the initial Linux port of the source engine and the Steam client. Did lots of OpenGL performance work, worked on kicking off SteamOS, and then later things like Vulkan, SteamVR for Linux. In the past couple of years, I've worked a lot on setting up all of our external open source project contributions. Some of it you might have seen today around the Mesa project, and maybe in the coming days at the event as well. So a quick update on GameScope. So what is GameScope? GameScope is essentially the continuation of Steam Comp Manager. It's a rewrite, refactor of Steam Comp Manager to be based on Wayland instead of GLX. So Steam Comp Manager was or still is, the GLX-based compositing window manager at the core of the SteamOS gaming shell. So it either presents Steam or a single game in a full screen way, nicely scaled up with pillar boxing or letter boxing if needed, V-synced, all that kind of, or what we call the appliance-like session. So by moving over to Wayland and X-Wayland, we're able to basically do the same thing and display a single game running in that X-Wayland instance. But we more directly assume the role of what would be the responsibility of the DDX back then, and we get to then decide what we do with the incoming app buffers, and either short circuit any sort of graphics and go directly to DRM display output, or if we need to composite something, the new code uses Vulkan only, so that by using Vulkan Compute, we're actually able to schedule any work needed on the async compute ring of the hardware if the hardware does support that, which is pretty useful in some situations. It's also optimized for latency, so it tries to be very aware of the underlying VBlank timing of the output display device when it's running in that direct DRM embedded mode, and tries to align the game's rendering to that and decide which of the most recent buffer to composite or display at a tight deadline before the next VBlank. So that's the basic kind of rendering loop here. You see VBlanks are the vertical purple bars. This is running on AMD hardware, so we're able to use that real-time compute capability in that separate hardware ring. Here you see the game running. Sekiro is very intensive for the system apparently because it's keeping the GPU completely busy. But despite that, we're able to get scheduled at our budget before VBlank, sneak in some compute work even though the GPU is completely busy, and still make our frame there. So for the whole Wayland aspect of it, I use WL roots. Seemed to be a pretty quick starting point and to fit our needs as far as not having too high level of an abstraction, because I knew that there's some parts of it we would need to completely stub out and replace with our own, such as the whole output portion with graphics and the window manager as well, where we substitute WL roots with our own window manager, still based on the previous Steam Comp Manager code base. So once I managed to hack around these mismatches, it was pretty painless. I started from Rootston, which was, I guess, an example compositor based on WL roots. It had a nice disclaimer at the top saying, under no circumstances you should fork this and create your own compositor from it. So I did that, and then once that was up and running, merged it with the Steam Comp Manager code base, and then started to plumb the output pipeline of Steam Comp Manager to Wayland by putting my own sideband to export the DMA buffs from Wayland. And once that was running, I just had to remove the Rootston part of it to get back to a normal size and bare bones functionality. So in that intermediate state, it looked a little bit like that, where it had both the Rootston window showing a more traditional desktop and or more like managed, scaled, nicely presented output window. which was pretty interesting. So as part of developing it, I was mostly using a desktop session because Wayland and its compositors usually have some sort of nested support where you can just run them on a normal desktop. And was mostly using that as a development tool because it was convenient. But I was running through that stuff, realized that the same architecture, the same code base could actually let us achieve some of our goals around doing the same sort of input-output manipulation of the pre-existing game without modifying the game, but applying that to a more general Linux desktop, which was really interesting. So it seemed like we could hit two walls with one stone here, which I tried to pursue some more and added some initial features to see what we could get out of that nested desktop use case instead of just focusing only on the embedded one. And I'm going to show some of my takeaways there. The initial thing that it obviously does is to abstract away, all the size of the output. So, if you have a game, you're able to put it full screen, and and that's pretty straightforward. It's nothing that Steam Comp Manager couldn't do. But say you have an ultra wide screen. Here, I put my monitor in its native 21:9 mode. Some old games will probably not do the right thing when faced with these kind of modes. Newer ones support them just fine in most cases, or at least have a fallback to 16:9 with pillar box. But some older games will just never be made to work well there. So here, is Portal. You get to pick your poison in there, but no matter what you pick, it's not going to work quite the way you'd expect and not give you, both full screen and not broken rendering. But if you run it through GameScope, which is a very easy command line, just append or prepend GameScope with 2560 height 1440 to make its internal display a 16:9 and pointing the game at that, so it runs in that little sandbox. Then as far as the game's concerned, it's running on a single 16:9 display, and then all of the output transformation around putting these pillar boxes around the rendering and overlaying the rest is done through GameScope. So it works more as you'd expect there, and latency is good and all that. Similar situation on multi-screen scenarios like multi-monitor. Some games will either get endlessly confused by multi-monitor configurations and just pick one display and be insistent that they need full screen to that one, and then not react well when you forcefully uproot them and put them to the other display. Or some games, if you have like a portrait display and a landscape display, some games will get very confused by the overall desktop resolution and all that. If you run it through GameScope, as far as the game's concerned, it has one display. It has no way of hurting itself there. So you can just unfull screen it through GameScope, drag it to your other display, and there you go. It solves that whole class of issue as well. It can do some interesting things around refresh rate as well. So by default, I can run this GLX Gears OpenGL benchmark, and it'll naturally pass through my host desktop refresh rate of here 100 Hertz to the app. So it's running at 100 Hertz right now. But should I decide to, I can just tell it to fake it and run it at a refresh rate of 30 Hertz, which can be useful in some cases if you need to cap an application. And some ad hoc tools have existed to do that for a long time, where you can just hook to a variety of graphics APIs and try to get the same thing going. But here it's a nice general solution and work across the board. And then you can imagine more quality of life type features where here I have this mode where it limits the refresh rate, but only if the GameScope window is out of focus. So here it's running at my native 100 when I'm trying to interact with the app, and then as soon as I Alt Tab, it's throttling down to 10 FPS. So say you're gaming on a laptop and you want to have your laptop get a little bit cooler if you need to Alt Tab from the game, or not be burning all that battery life. Maybe you can do that now. The fact that it has this unified Vulkan-based output pipeline in the nested scenario is pretty interesting too. It means that you can, for example, use the VK Basalt post-processing Vulkan layer on a variety of applications that it would otherwise not support. So, for example, here I can run it with GLX Gears, and make use of its CRT filter that would only apply to Vulkan apps normally, and in conjunction with GameScope's own feature of disabling filtering and doing that nearest neighbor filtering, you can get this nice retro output going there. Same idea, you can just extend that to core rendering as well, because everything goes through that same output pipeline. So it's general solutions to things that were previously hacked together, and I think it could be pretty convenient if exposed properly with a nice UI. So I mean, there's still some work to do. Definitely more polish around that nested experience. Like, that's just starting at this point. Mimic more the game window, pass through the window title, window icon, a couple of different things that would just make it act more as you'd expect as the user. Of course, we need NVIDIA support as well. Like, it works on Mesa drivers right now, but all of the NVIDIA stuff is off limits because of its reliance to X-Wayland right now. On the embedded kind of core use case, we really need to be able to make more use of DRM planes when possible. And right now it's mostly not possible because of kernel bugs, but it's one of the main things that still forces us to composite when we have additional layers, on top of the game's rendering. There's a couple of, I think, high-level takeaways. We really need modifiers. Like, right now we're focusing on the Vulkan case because we're running the same Vulkan driver on the compositor side and the client app side in the most common case you care about. So we can we can get optimal rendering or optimal surface layout there and just have it match by chance. But for OpenGL, for example, we have to disable all the internal driver compression optimizations and all that, because otherwise our rendering would be garbled, and having modifiers plumbed everywhere is really needed there. Implicit sync's not ideal. It'd be better, I think, if we got an explicit fence if we wanted it, that we could even wait on the GPU. That would be best. There's a bunch of bugs in display drivers on the kernel side. I don't think that's news to anyone. Anytime you're going off the well-trodden path of just doing a native resolution, main plane scan out, you run into issues. And so I'm sure we'll run into more of them, and hopefully that'll be a forcing function to get some of that stuff fixed. It'd be really nice to get tighter control over the application's rendering cadence so that we could do further things to align its frame, the application frames to VBlank and reduce latency even further. There's some hacks we can do right now, but it'd be nice to have a real mechanism to dictate when things like swap buffers or acquire next image returns, so we could meter it really accurately. And yeah, that's mostly it. I didn't have tons of time, so I tried to go through it quickly, but let me know if you have more questions, and check out the project. It should work pretty well on desktop today, at least on AMD hardware. Intel's probably not too far off from working as well. Thank you.